Hello everyone and welcome. We are very excited to share the NorthStar facility expansion project with you today. I am John Savage, a senior structural engineer and project manager at HDR. With me today I have Josh Christensen, a structural EIT who also worked on the project.
NorthStar facility expansion is located in Omaha, Nebraska and is made up of two separate additions on the north and south side of their existing building. Overall, the project added 32,000 square feet of new construction along with renovations and upgrades to the existing space. The construction cost of $13.4 million was all privately funded. The design team was challenged to create not only a building for the students, but also one that would draw attention and interest from the public. The design team wanted to play off NorthStar's mission of uplifting and elevating students, and you'll see that mission paired with the theme of aircraft repeated throughout this project.
If you are not familiar with the NorthStar Foundation, it is a nonprofit after-school program for underprivileged boys in North Omaha that provides programs dedicated to academics, athletics, arts, and social programs. The original facility was designed for 100 middle school students. 80% of NorthStar boys reside in homes with a family income of less than $30,000, and 86% are raised in single-parent homes. Nearly every NorthStar student qualifies for the federal free and reduced lunch programs. As the first wave of 8th grade students aged out of the program, some of them wanted to return to NorthStar to continue their program through high school. Not wanting to turn the students away, the staff hosted them wherever they had space, in hallways, lounges, and even the nurse's station. By 2018, the program had grown to serve 600 young men, with daily attendance exceeding 180 students. Now with their new additions, NorthStar plans on serving over 850 boys annually with about 300 daily students. As part of HDR's STEM partnership with NorthStar, HDR brought a group of older students into the early design and planning process to let them contribute ideas and needs for the new spaces. By integrating the students into the design process, there was tremendous anticipation and buy-in from the students for the building additions and NorthStar's future.
These floor plans show the north and south additions in white with the existing building between the two in gray. With the rising facade and cantilevered floors, the North Addition is now the main focal point of the facility. The North Addition is 2 stories and contains 6 classrooms for elementary students. It also has a mindfulness room, learning stair, and at the far north end is the boardroom. On the east side of the building is an extensive gallery space framed by the rising monumental stairs and full-height curtain walls. The North Addition also reworked the main entry to the building, allowing for more waiting space in the vestibule and tighter security. The South Addition is programmed for high school students. It has smaller individual study rooms used for tutoring and focus work. On the west side of this addition is the Innovation Hub, which is a flexible lab space that can be used as part of NorthStar's STEM program and robotics program. The South Addition also provides a large open dining area, which is highlighted by a Piper Cub airplane hanging from the roof joists. Now we want to highlight the overall structural system before diving deeper into each unique piece of this project. Structural steel was an obvious choice from the very beginning of the design process. Not only did it match the existing structure type, but it also allowed for shallow floor depths, large open bays, and relatively light column loads that could be supported off of shallow, spread footings on the poor soils. A concrete system was not selected because of the lack of formwork repetition, the schedule impacts, and the amount of field labor required. Timber was also not selected due to the large open bays, facade requirements, and the architect's desire for large cantilevers. Keeping the cost of the structural system to a minimum while integrating it into the architectural vision was a big challenge for this project. This meant keeping the structure as efficient as possible, and structural steel was key to turning that desire into reality.
As part of NorthStar's STEM focus, HDR's designers realized that the building itself could be used as a teaching tool. Therefore, most of the structural framing was left exposed to view. Lateral loads are resisted by braced frames utilizing rods, turnbuckles, and clevises. The rod braces were inspired in part by the wire braces between the wings of early biplanes. Because the braces and gussets are exposed to view, the structural team worked closely with the design architects to detail the gusset plates in an aesthetically pleasing manner. This is most evident in the North Addition, where the high bracing loads required a set of double rod braces and an amoeba-shaped gusset plate at the rod intersection.
The learning stairs are a great example of the unique and different spaces that the new addition brings to NorthStar that they previously did not have. They provide an informal gathering space for students and can also be used for group presentations. The learning stairs are framed with sloping, wide-flange raker beams. Concrete on metal deck was formed to create the treads for the sitting areas. The smaller treads for the stair steps were then placed in a second pour to help with constructability. Using steel framing for the learning stairs allowed the open area underneath the stairs to be used as additional space for the mindfulness room.
While it looks simple, the curved entry vestibule presented many challenges. The new two-story vestibule provides a more prominent entrance than the old building did, and it also provides protection over the entry doors. To build the addition, the existing atrium first needed to be selectively demolished and resupported to allow space for the new vestibule. The addition is separated from the existing building by an expansion joint, so the demolition and new support columns needed to be detailed in a manner that allowed for a relatively straight expansion joint in order for the joint to function properly. At the same time, potential column locations were limited due to existing footings, the open floor plan, and the function of the space. As will be discussed later, the design team tried to keep a consistent beam spacing and layout throughout the north atrium. The curvature of the vestibule required radiused and cantilevered HSS beams at the perimeter of the roof to support the curtain wall, which made it more difficult to achieve this uniform layout of the roof framing.
Unexpectedly, the monumental stairs are one of the top things the NorthStar staff enjoys. The stairs provide an opportunity for them to have a direct path to the second-level boardroom while not interrupting the students, but at the same time seeing all the activities happening in the space. The monumental stairs follow the slope of the rising exterior facade, which is a major architectural focal point of the addition. To further emphasize this rising facade, the architects wanted to cantilever the stairs over the exterior brick wall. To keep the cantilevers at the stairs to a minimal depth, it was decided to hang the curtain wall dead load from the roof level. The stringers and concrete slab were used as a horizontal diaphragm to transfer lateral wind loads from the curtain wall back to the interior columns. The rising elevation of the stringers resulted in varying bending moments in the columns. The columns were therefore designed to resist the vertical gravity loads, moment from the cantilevered stairs, and moment caused by the lateral forces near the mid-height of the columns. The functionality of the rise and run was critical for the monumental stairs to be successful. It was crucial that the person ascending or descending the stairs be able to use a natural stride and cadence. Therefore, the architectural team made mock-ups of the stairs to test different rise and run combinations to ensure the stairs were properly dimensioned. Another key feature of the monumental stairs is the solid steel panelized guardrails. The panels on the stairs are repeated along the entire perimeter of the second-level balcony. The architectural team wanted to use the solid panels in lieu of glass or other open railings to further emphasize the rising facade and the theme of uplifting and elevating the students.
At the far north end of the addition, and the highest point of the rising facade, is the second-level cantilevered boardroom. This is a major architectural piece and the focal point of the north addition. To keep the space below the boardroom accessible, the floor framing needed to be as thin as possible. The design team knew that cantilevering the floor framing 14 feet would be too deep, so the floor is suspended from cantilevered roof beams. To match the aesthetic of the braced frames used in the building, vertical rod hangers with turnbuckles and clevises were used to hang the boardroom floor. The rod hangers were coordinated to be in line with the curtain wall mullions to lessen their visual impact, which meant that the rod hangers were not at ideal structural locations, adding even more complexity.
As we have mentioned, the design team was challenged to find ways to save project costs throughout the design. Dovetail acoustical roof deck was used in the lobby of the North Addition and at the clear story of the South Addition to help reduce project costs. The exposed deck provided an acceptable architectural finish that allowed ceilings and acoustical clouds to be removed from the project. It also allowed the framing members to be spaced further apart, taking advantage of the long span capacities of the deck and reducing the number of framing members. Since the framing and deck is now exposed to view, the architectural team wanted the framing to be consistently perpendicular to the deck span and to use the same nominal depth purlin beams. Typically, this would not be unique, but as the building curves near the vestibule, the roof framing started to become skewed to the girders and column grids. Skewed bolted connections required close coordination with the fabricator and erection team to ensure capacity was achieved while balancing constructability. As you can see, the fully integrated design team at HDR worked with Kiewit and Sioux City Foundry to meet the owner's needs while creating a unique, transformational project that would become the new face of NorthStar. We would like to thank NorthStar for the opportunity to work with them on this project. HDR is proud to play a small part in growing NorthStar's impact on the community. We'd also like to thank AISC for giving us the chance to share this project, as well as the judges for their time.